Good evening. Good evening, ma'am.
Good evening, sir.
Yeah, Jay. Went to school today.
Yes, sir.
All right. We'll continue. Yesterday, we were talking about the chemical properties of haloalkanes. We'll continue with that. Few of the reactions we learned yesterday, that is two types of reactions alkyl halides will undergo. One is nucleophilic substitution reaction. The other one is elimination reaction. Nucleophilic substitution reaction is represented as SN. What is a nucleophile? Nucleophile is an electron-rich groups. Electron-rich groups or electron-donating groups. Donating groups. They are called as nucleophiles. Generally, they will be negatively charged. There are neutral nucleophiles also. Now, coming to the term electrophiles, electrophiles are electron deficient group, or electron attracting group, or electron withdrawing group. Generally, they will have positive character. So nucleophilic substitution reaction, we will be learning the mechanism in detail. That is SN1 and SN2 mechanism we will learn later. Now coming to some of the simple reactions, nucleophilic substitution reaction, we learned hydrolysis. Alkyl halide, when allowed to react with silver hydroxide, silver and halogen gets eliminated as AgX. In place of X, what gets bonded? OH. Therefore, you get an alcohol. For an example, we take ethyl bromide. This ethyl bromide, when allowed to react with silver hydroxide, what happens? AgBr gets eliminated, and in place of Br, OH goes. Therefore, you get C2H5OH, ethanol. Likewise, alkyl halide, C2H5Br, when it's allowed to react with aqueous potassium hydroxide. See, aqueous means water. Aqua represents water. K and Br gets eliminated as KBr. In place of Br, OH goes. Therefore, you get C2H5OH, alcohols. So whenever an alkyl halide is hydrolyzed, the product what we get is alcohol. Remember, they can ask you a question, how an alcohol is prepared from alkyl halide. So you should know that whenever alkyl halides are hydrolyzed, we get alcohol. With the help of this reaction, alkenes can be converted into alcohols. Alkenes can converted into alcohol with the help of what reaction? The above reaction. What is that we are doing? Now, alkene, ethylene or ethene, when it's allowed to react with hydrogen bromide, hydrogen attacks this carbon, bromine attacks this carbon, therefore one of the pi bond will break. So you will get ethyl bromide, CH3, single bond CH2, single bond Br, ethyl bromide. This ethyl bromide is an example for alkyl halide. This alkyl halide, when you hydrolyze with silver hydroxide, what happens? You get AgBr as a byproduct. In place of Br, what goes? OH goes. Therefore, the product what we get is ethyl alcohol. Similarly, we learned yesterday reaction with alcohol oxide. Now, what is this alcohol oxide? Now, if you take ethanol, now this ethanol contains a OH group. If you react it with sodium metal, sodium is more reactive than hydrogen. Therefore, sodium will displace hydrogen to get C2H5ONa. This will be called as sodium ethoxide. It will be called as sodium ethoxide. It is an example for alcohol oxides. Alcohol oxides. So sodium ethoxide is likewise, any alcohol when it's allowed to react with sodium metal, you get sodium alcohol oxides. Now, alkyl halide is Rx, it is a general representation. Specific example, if you take ethyl bromide, and if you allow it to react with sodium ethoxide, NaOC2H5. So C2H5ONa, I've written it as NaOC2H5 because I can show you the elimination of NaBr. When NaBr gets eliminated, what do you have now? C2H5, and you have an oxygen, and you get C2H5. This is an ether. It is an ether. It is an ether. Now, similarly, the next reaction is alkyl halides, C2H5, okay, C2H5Br, C2H5Br, alkyl halides. When allowed to react with dry silver oxide, what happens? Silver and bromine gets eliminated as 2AgBr. And what else you have now? C2H5, and you have an oxygen, and you have C2H5. This is also an ether. You can prepare ether by the reaction of alkyl halides with silver oxide, dry silver oxide. It should not be moist. If it is moist, it will undergo hydrolysis to form alcohol. So similarly, the last reaction yesterday, what we learned is reaction with sodium or potassium hydrogen sulfide. So it is represented as NaSH, sodium or potassium hydrogen sulfide. Now, the sodium or potassium hydrogen sulfide is allowed to react with an alkyl halide. I'm taking ethyl bromide, simple reaction, so simple molecule. So what happens? Na and Br gets eliminated as NaBr. In place of Br, what goes? SH. Therefore, you get C2H5SH, right? So this is also similar to what? An alcohol only. Did you follow this so far?
Yes, sir.
Yes, sir.
Ajay,
Yes, sir.
are you there? Anybody? Can you hear me talking?
Yes, sir.
Sir, yes, sir.
Yeah, please respond. The next one is reaction with potassium nitrite or silver nitrite. Potassium nitrite or silver nitrite. Potassium nitrite, NiTrite. So KNO2, or it is AgNO2. Nitrite ion, NO2 minus ion is called as nitrite ion. This nitrite ion we can represent like this. This KNO2 will dissociate, we can represent this as K plus O single bond N double bond O. And oxygen will have a negative sign. This is a representation. K plus and NO2 minus. K plus and NO2 minus. Now an alkyl halide like ethyl bromide, C2H5Br, when it is allowed to react with potassium nitrite. Potassium nitrite. So Br is negative. So what happens? K and Br gets eliminated as KBr. KBr. In place of Br, what gets bonded? O and double bond O. So you get C2, this is an arrow mark. So you get C2H5O single bond N double bond O. This is called as ethyl nitrite. So whenever alkyl halides are reacted with potassium nitrite or silver nitrite, the product what we get is alkyl nitrate. See, you should remember ONO minus and NO2 coordination compounds we learned, and we learned it as an ambidentate ligand. What do you mean by ambidentate ligand? A ligand which has two donor atoms will be called as ambidentate ligand. Here, oxygen behaves like a donor atom. Here, nitrogen is behaving like a donor atom. When we use potassium nitrite, oxygen behaves like a donor atom. Therefore, you will get alkyl nitrite. But if you see here, when we are using silver nitrate, C2H5Br, when it's allowed to react with AgNO2, AgBr gets eliminated. And what is formed? C2H5NO2. So nitrogen becomes a donor atom here. So this will be called as nitroethane. It will be called as nitroethane. See, there is a difference. When the oxygen atom is donor, it will be called as nitrites. And nitrogen atom is donor, it's named as what? Nitroalkane. Did you understand the difference, students?
Yes, sir.
You understand the difference. So you should remember
Yes, sir.
what type of nitrite ion has been used, whether it's potassium nitrite or silver nitrite. Next, we have the reaction with ammonia. See, this reaction with ammonia is called as ammonolysis. We will learn ammonolysis now in detail. Now, the statement goes like this. When ammonia is allowed to react with alkyl halides, or ammonia is heated with excuse me, ammonia is heated with alkyl halide at 100 degrees Celsius in a sealed glass tube. A mixture of primary, secondary, tertiary, and quaternary ammonium salts are formed. So ammonolysis, reaction of alkyl halide with ammonia. So when ammonia is heated with alkyl halides at 100 degrees Celsius in a sealed glass tube, you will get a mixture of primary, secondary, tertiary, and quaternary ammonium salts. Now, how do we understand this reaction? It's there here. The four reactions are represented here. We will write in detail and we will try to understand this. Now, this is a reaction which can be used to differentiate primary, secondary, and tertiary amines. This is the reaction. Amines, organic compound containing NH2 groups, are called as amines. So we have primary, secondary, and tertiary amine. So by ammonolysis, or by reacting the alkyl halide with ammonia, we can differentiate between primary, secondary, and tertiary amines. Now, what is this ammonolysis? I will write here because I need space, so we will write here. What is this ammonolysis? Now, alkyl halide, we will take a simple example, that is C2H5Br. When this is allowed to react with ammonia is NH3, we will write it for our convenience as NH2 and H. It at 100 degrees Celsius in a sealed glass tube. What happens? H and Br gets eliminated as HBr. In place of H, what goes? C2H5. Therefore, what is that you get? You get C2H5NH2. Now, this is primary amine. Why it is called as primary amine? Because nitrogen is bonded to only one carbon atom. That is, if I write the structure like the CH2, CH3, CH2, NH2. So when this nitrogen is bonded to only one carbon atom, therefore this is a primary amine. Primary amines. So what's the name of this molecule? The name of this molecule will be 1, 2. So we have 2 carbon atoms. Therefore, it will be called as ethane. And you have a single bond, ethane, and remove this E and write amine. So therefore, it will be called as ethane amine, ETHAMINE, ethane amine. Now, you should understand, if this hydrogen can be replaced by C2H5, the other 2 hydrogens also can be replaced. So what happens is, this is the first step in the reaction. The second step in the reaction is, now alkyl halide, we will write C2H5Br, and I will write HNH, and I will write C2H5. This is the molecule I'm writing. It's a continuous process. So what happens now? H and Br gets eliminated as HBr. In place of H, what goes? C2H5. So what's the molecule you get? C2H5, sorry, NH, CH2, CH3. This C2H5, I'm writing it as CH2NH3. So if I number it, it's a longer chain. Root word will be eth. Carbon to carbon single bond, ethane. And it has an amine group, therefore ethane amine. But you have a substituent here. This is called as ethyl. Ethyl ethanamine. This ethyl group is bonded to nitrogen. Therefore, it is called as what? N-ethyl ethanamine. What does this N stands for? The N stands for the substituent is bonded to nitrogen. Now you can see this N-ethyl ethanamine, it is a secondary amine. Why it's a secondary amine? This nitrogen is bonded to 2 carbon atoms. It's a secondary nitrogen atom. Therefore, it will be secondary amine. Now coming to the next reaction, the third step of the reaction, we'll take an alkyl halide C2H5Br and I write HN C2H5 and I write C2H5. See, this is what I'm writing, C2H5 twice, I'm writing it like this, and H I've taken this side for our understanding. What happens now? H and Br gets eliminated in place of H, C2H5. So what do I have now? C2H5, En, C2H5, I have CH2 and CH3. Now, see, this is a nitrogen atom which is bonded to 3 carbon, 1, 2, and 3. This is a tertiary nitrogen atom. What will be the name of this molecule? So, ethanamine. Parent name will be ethanamine. But 2 substituents, C2H5, C2H5. Therefore, it will be diethyl ethanamine. This diethyl, 2 ethyl groups are bonded to nitrogen. Therefore, it is written as N, N diethyl ethanamine. Did you understand the naming part of it?
Yes, sir.
Now, the fourth step is this compound which is formed. I will write like this, C2H5 thrice N. Can I write C2H5 thrice N? Yes. And nitrogen has a lone pair of electron. When this is allowed to react with alkyl halide, like maybe we can write it as C2H5Br. Now what happens is, now this electron pair will be taken by bromine and you will undergo heterolytic fission. Bromine gains minus charge and carbon gains positive charge. So what happens? This pair of electron is donated to C2H5. When this pair of electron is donated to C2H5, I can write C2H5 N C2H5 single bond C2H5 and I'll write C2H5. Since this carbon atom has a positive charge, now whole of this will get a positive charge and you will get what? Bromine. See, 3 bonds are covalent bond. This is covalent, this is covalent, this is covalent. 1 is a coordinate bond. Why? In this case, a pair of electrons is donated to ethyl group by nitrogen. So when both the electrons are donated by one atom, the bond formed is called as a coordinate bond. And here you can see plus and minus. This is called as tetraethyl, tetraethyl ammonium bromide. So this tetraethyl ammonium bromide, what we're talking about, it has 3 covalent bonds, 1 coordinate bond, and also we have ionic bond. All the 3 types of bonds are present in this molecule. Now this process is called as ammonolysis. Now how do you differentiate primary, secondary, tertiary amine? So if you start the reaction with primary amine, finally for the formation of this molecule, it consumes 3 moles of alkyl halide. Primary amine will consume 3 moles of alkyl halide. Now, if you start the reaction from secondary amine, to complete the reaction, secondary amine will consume how many moles? Secondary amine will consume 2 moles of alkyl halide. Now, if you start with a tertiary amine, it will react with only 1 mole. Tertiary amines will react with only 1 mole of alkyl halide. So you can differentiate the primary, secondary, tertiary amine based on the number of alkyl halides consumed. If an alkyl halide consumes 3 moles, it will be called as primary amine. If the alkyl halide 2 moles is consumed, then secondary amine. And if the alkyl halide, 1 mole of alkyl halide is consumed, it's called as a tertiary amine. Did you follow this? This reaction
Yes.
is called as ammonolysis.
Yes, sir. Follow, sir.
Yeah, the next question we will learn. So this is how the reaction, same reaction I explained it in other ways. So tetraethyl ammonium bromide, it's a quaternary ammonium salt. All right, these all are common names: ethylamine, diethylamine, and triethylamine. They are common names. What names I made you write here, or I made it's N-ethyl ethanamine, N, diethyl ethanamine. These all are IUPAC names. So remember. Now the next set of reactions, that is reaction with silver salt of fatty acids. Reaction with silver salt of fatty acids. Now, silver salt of fatty acids. Now, fatty acids are organic acids which contains even number of carbon atoms. It's a long chain carboxylic acid containing even number of carbon atoms. Butyric acid, stearic acid, palmitic acid, oleic acid, all these butyric acid is present in butter. Oleic acid is present in the oils, coconut oil, groundnut oil, all that. All right. So those carboxylic acids, when allowed to react with a silver hydroxide, you get silver salt of fatty acids. The silver salt of fatty acids are represented as R-COOAG. This is R- is a long chain, and again it is called as alkyl groups, long chain alkyl groups. Now alkyl halide, we represent it as Rx. So what happens when silver salt of fatty acids are allowed to react with Rx? What happens? Ag and X gets eliminated as AgX. In place of Ag, R goes. So what's that you get? You get R-C/R. It is called as an ester. It is called as an ester. So it will be R-C double bond O single bond O R. So any organic compound which contain C double bond O and O as a functional group is called as esters. So reaction with silver salt of fatty acids. So silver salt of carboxylic acids or fatty acids, when allowed to react with an alkyl halide, you get an ester. Followed? The next reaction is, the next reaction is reaction with sodium acetylide. Sodium acetylide. Now, what you should remember is, now this is an alkyne. What are alkynes? Molecules in which we have minimum of 1 carbon to carbon triple bond is called as an alkyne. This is ethyne. Now, hydrogen atoms attached to carbon containing a triple bond is called as acidic hydrogen. Acidic hydrogen. The character of these hydrogen atom bonded to carbon containing a triple bond are acidic. These all are acidic. Now, when we say these all are acidic, when it is allowed to react with a base, like a metal like sodium, what happens? The sodium is being reacted to displace hydrogen. So you get HC triple bond C Na. This is called as sodium acetylide. Sodium acetylide. So sodium acetylide is written here, NaC triple bond CH. All right, when it's allowed to react with alkyl halide, what happens now? H and X gets eliminated, Na and X gets eliminated as NaX. In place of Na, what goes? R. Therefore, what we get? R single bond C, triple bond CH, alkynes. We can prepare higher alkynes. Higher alkynes can be prepared by the reaction of alkyl halides with sodium acetylide. You understood what is sodium acetylide? Sodium acetylide is nothing but an alkyne in which acidic hydrogen is replaced by sodium. Those are called as sodium acetylide. So in specific, this is otherwise called as sodium ethanide because this is ethyne. So it is named as sodium ethanide. Now, if you're using propine, it will be called as sodium propionate. All right. So acetyl is a common name. Therefore, they've named it as sodium acetylide. It's a common name. It's not the IUPAC name. All right. A lot of reactions. Are you following little at least?
Yes, sir.
Yes, sir. Following.
Now the reaction with sodium or potassium sulfide. Sulfide means S2 minus ions. Sulfides are called as represented as what? S2 minus. It is not sulfate, sulfides. Now alkyl halides, we'll take an example, CH3Br, and simple example CH3Br. And when sulfur react with sodium sulfide, Na2S. See, sulfur has 2 minus charge. Sodium has +1 charge. Therefore, to balance the valency, it is Na2S. Therefore, we are taking 2 moles of alkyl halide. What happens now? 2Na and Br gets eliminated as 2NaBr. Now, what else you have now? You have CH3, you have S, and you have CH3. It is like ether only. If you have oxygen here, it will be called as ether. Since we have sulfur, it is called as thioether. Sulfur is called as thio groups, thiols. Sulfur containing compounds are called as thiols. Therefore, it's called as what? Thioether. So what do you mean by thioether? Sulfur, when it's bonded between 2 alkyl groups, then it is called as what? Thioether. Now, if you observe, in the beginning of the class today, we were discussing about ethers here. See, oxygen. Any molecule which contains oxygen as a functional group is called as what? Ethers. Now here, if the functional group is sulfur, then it is called as thioether. Where is the thioether? All right, your sulfur is the functional group. So the reaction with sodium potassium sulfide, we get thioether. So thioethers also can be obtained by the reaction of alkyl halides with sodium NaSCH3, sodium sulfur and alkyl groups. So you can, this also gets eliminated, NaBr gets eliminated, and you will get what? An alkyl group, sulfur and an alkyl group, ethyl, methyl, thioether. The last part of the reaction, maybe from this part, is reaction with halides. When we say reaction with halides, alkyl halides, when allowed to react with sodium bromide. Bromine is more reactive than chlorine. Therefore, sodium chloride gets eliminated and you will get what? In place of Cl, Br goes. So RBr, alkyl bromide. This alkyl bromide, when allowed to react with sodium iodide, NaBr gets eliminated. Iodine is more reactive. This iodine will replace bromine. So you get alkyl iodides. So that is why we call it as what? Reaction with halides. All right. Followed? Now, this what we missed out here, the word, not missed out, what I didn't mention, NaSR dash, it's called as mercaptides, sodium mercaptides. Sodium mercaptides. Mercapto is also sulfur containing compounds. All right. So this is called as sodium mercaptides in general. So this is the chemical properties of alkyl halides. Now, these are the reactions, what we learned, the reactions called as nucleophilic substitution reaction. The second set of the reaction is called as elimination reaction. Clearly, the name says elimination reaction. Elimination means removal of something. Now, elimination reactions, the positive charge on carbon is propagated to the neighboring carbon atoms by inductive effect when approached by a strongest base. It tends to lose proton, usually from the beta carbon atom. Such reactions are called as elimination reactions. They're also called as E1 and E2 reactions. E stands for elimination. Now, what is this? A positive charge, we'll take an example and we will learn. So a positive charge on the carbon, is propagated to the neighboring carbon atoms by inductive effect. When approached by a strong base, it tends to lose proton. Usually from beta carbon atom. Such reactions are termed as elimination reaction. Now, E1 reaction. See, this is an alkyl halide. We will take this alkyl halide in specifics. CH3, CH, you have hydrogen, you have CH, this is bromine, and this is hydrogen. It's a primary alkyl halide. It's propyl bromide. 1, 2, 3 carbon atom, propyl bromide. Now, in propyl bromide, this propyl bromide will undergo ionization reaction. So what happens? This bromine will gain negative charge and gets eliminated as Br minus. When they get eliminated as Br minus, this carbon is losing an electron. Therefore, carbon gains positive charge. So what's that you get? You get CH3, CH, here you get H, you have CH, you have H, and this is a positive sign. This is called as carbocation, positive sign, because both the electrons are gained by bromine. Now, when a strong base approaches them, when a strong base, we represent as minus sign here, B minus, strong base approaches them. Lewis base, electron pair donors are called as base. When strong base approaches them, what happens is the molecule, the ion tend to lose a proton, usually from beta carbon atom. Tend to lose a proton from beta carbon atom. So what is this beta carbon atom? Now, this is a carbon which was containing a functional group that will be called as alpha. Next to alpha, what it was, it is beta. So this hydrogen will be lost. When this hydrogen lost, there will be a double, this bond will shift here. So what happened? This positive sign will get neutralized. So what do I have now? I have CH3, CH, single bond CH, single bond H. But what will be formed here? A double bond will be formed here. An alkene is formed. See, this B and H gets eliminated as BH. That's what they've showed. So alkene can be prepared by the elimination reaction of an alkyl halide. This is called as E1 elimination. Now, similarly, when we talk about the E2 elimination, this looks a little complex. Let's see. Now, this is an alkyl halide, right? We will write the alkyl halide like the CH3, CH, CH, here H, here Br, and here it is H. When a strong base approaches them, this alkyl halide, what happens is this base forms a partial bond with hydrogen. This base starts attacking the hydrogen. When base starts attacking the hydrogen, what happens is, now it's a slow process. So there will be a bond formed between, partial bond formed between hydrogen. And what happens is CH3, you have CH, you have CH, H, you have a halogen here, bromine and X. So what happens is, now carbon valency is 4, hydrogen valency is 1. When this base is starting to attack this hydrogen, hydrogen cannot have valency 2. Therefore, this bond will shift. When I say this bond will shift towards this carbon atom. Now, when this bond is shifting towards this carbon atom should have only 4 bonds. It cannot have 5 bonds. Therefore, to attain the stability, this bond shifts on bromine. So this is called as transition state. Now, what happens? The next step you see, you get CH3, you have C, you have H. What happened? This gets eliminated. This bond shifts here means what happened? BH gets eliminated. So CH, since this bond shifts here, a double bond will be formed between carbon and carbon. And you have this hydrogen here. And you have what? A hydrogen here. And what gets eliminated? Br minus gets eliminated. Not only Br minus gets eliminated, this Bx also gets eliminated. BH also gets eliminated. So again, this is called as an alkene. So this is called as E2 elimination. So in E1 elimination, ionization takes first and the base attacks, forming an alkene. In this E2 mechanism, what happens is the base attacks the alkyl halide and goes into a transition state and then loses the halide and the BH, forming an alkene. There's a simple difference, a minor difference between E1 and E2, but both are called as what? Elimination reaction. I hope you follow this.
Yes, sir.
Now, as the above reaction involves leaving of X minus, the reactivity of alkyl halides, same alkyl group, different halides, should be limited with carbon, oxygen, carbon and halogen bonds. The reactivity of alkyl halides, same alkyl group, different halogen, should be limited with the alkyl halogen bond. Now you can see the type of bond, carbon-hydrogen bond strength is 45.5. Lesser carbon-chlorine bond, the bond strength is 66.5. So the breaking of bond becomes more and more difficult. Thus the reactivity decreases. So when the halogen is chlorine, the reactivity will be slow because to break this bond takes time. If it is Ci, the bond strength is low. Breaking the energy will be, bond between C and I will be easy. Therefore, the reaction will be faster with respect to elimination E1 and E2. All right. Now, order of reactivity. Order of reactivity. Tertiary, secondary, and primary. Tertiary is more reactive compared to secondary. Secondary is more reactive compared to primary due to plus I effect. Due to plus I effect of alkyl group, which increases the polarity of carbon-hydrogen bond. See, carbon halogen bond, excess halogen. See, this is a tertiary carbon atom because this carbon atom bonded to 3 R groups. These alkyl groups are electron donating group. Alkyl groups are electron donating group. Since they are donating the electrons move towards the halogen. When the electrons are moving towards the halogen, what happens? The reactivity of tertiary carbon atom becomes more. Here you can see 2 R groups and the electrons are moving towards halogen. And here we have only 1 R group. So therefore, tertiary tertiary alkyl halides, order of reactivity is due to the plus I effect of the alkyl groups, which increases the polarity. Tertiary is more reactive compared to secondary. Secondary is more reactive compared to primary. Now, primary alkyl halides undergo either SN2 or E2 mechanism. See, primary alkyl halides will undergo SN2 or E2. I told you what is E2 mechanism. In E2 mechanism, base directly attacks what the alkyl halide, goes into the transition state and finally forming an alkene. Now, primary alkyl halides, you should know what is primary alkyl halides. Alkyl groups or primary alkyl halide, for an example, if you take CH3, CH2, H2 and Br. Now, this is a primary carbon atom because this carbon atom is bonded to only 1 carbon. This carbon contains halogen. Therefore, it will be called as primary alkyl halide. So, primary alkyl halides generally will undergo SN2 reaction or E2 mechanism, which involve the formation of transition state. The bulky group causes steric hindrance in the formation of transition state. Therefore, higher homologous series are less reactive than the lower homologous series. What is homologous series? You know, higher homologous series are less reactive compared to the lower homologous series because of something called as steric hindrance. Steric hindrance means availability of space because molecules are oriented in space. Atoms are oriented in space. So smaller alkyl halides are more reactive towards SN1, SN2 and or E2 mechanism compared to the higher alkyl halides because of steric hindrance. Examples of elimination reaction. Examples of elimination reaction. What are the examples of elimination reaction? The first one is called as dehydrohalogenation. What do you mean by dehydrohalogenation? D stands for removal. So removal of hydrogen and halogen simultaneously from neighboring carbon atoms or adjacent carbon atoms is called as dehydrohalogenation. So we cannot remove an hydrogen and halogen from the same carbon atom. Hydrogen and halogen has to be removed, will be removed from the neighboring carbon atom. So dehydrohalogenation means removal of hydrogen and halogen simultaneously from the neighboring carbon atoms. Now we will take an example. Before we could take an example, the reagent which brings about, reagent used for dehydrohalogenation is alcoholic potash. Alcoholic potash. What do you mean by alcoholic potash? Potassium hydroxide dissolved in alcohol is called as alcoholic potash. For a 12th standard, they will ask you for 1 mark. Give an example for a dehydrohalogenating agent. So the example for dehydrohalogenating agent is alcoholic potash. Alcoholic potash. So a stronger dehydrohalogenating agent we have soda amide, but it is mentioned very less time in your 12th standard, so you don't write that as an answer. But you remember soda amide, NaNH2 is also a dehydrohalogenating agent. So the reagent which brings about dehydrohalogenation is alcoholic potash. What do you mean by alcoholic potash? Potassium hydroxide dissolved in alcohol will be called as alcoholic potash. Now, what is dehydrohalogenation? We learned the definition of dehydrohalogenation: removal of hydrogen and halogen simultaneously from the neighboring carbon atom. Now, if you take an alkyl halide, we will represent an alkyl halide like this. Alkyl halide. This alkyl halide, when it is heated or allowed to react with alcoholic KOH, allowed to react with alcoholic KOH, what happens is, now K and Br gets eliminated as KBr. Now, since K and Br gets eliminated as KBr, we cannot eliminate hydrogen from the same carbon atom because bromine is eliminated. So the neighboring carbon atom, when we say neighboring carbon atom, this hydrogen and this OH gets eliminated as water. When this hydrogen and OH gets eliminated as water, what is left out? You have CH2, single bond, CH2. Can the molecule exist? Carbon should have 4 valency. Each carbon atom has 3 bonds because hydrogen and bromine is eliminated. Therefore, what will be formed? A double bond will be formed. A double bond will be formed, and the name of the molecule formed is ethene. Ethene is an example for alkenes. So when alkyl halides are subjected to dehydrohalogenation, the products formed is alkenes. The product formed is alkenes. So we understood what is dehydrohalogenation. What is dehydrohalogenation? It's a removal of hydrogen and halogen simultaneously from the neighboring carbon atom is called as dehydrohalogenation. All right. In this next one is, in this reaction, ether is a byproduct as potassium ethoxide always present in small quantity. In this reaction, so potassium ethoxide will be present in small quantity. Therefore, what happens? Now, ethyl bromide, this potassium ethoxide, what happened? K and Br gets eliminated as KBr. So what you will have? C2H5, O, C2H5. So this is an ether. So ether is a byproduct here in this reaction, always, because potassium ethoxide is present as an impurity in potassium ethoxide. Why potassium ethoxide is present as an impurity? This potassium hydroxide can react with alcohol to form potassium ethoxide. So not only that KOH dissolves in alcohol, but it also contains potassium ethoxide as an impurity. Since this potassium ethoxide is an impurity, ether is a byproduct in dehydrohalogenation. Followed?
Yes, sir.
The next reaction is action of heat. What's that action of heat we're talking about? We're talking about heating alkyl halides. So alkyl halides, C2H5Br as an example. We will write C2H5Br like this. The C2H5Br, when you heat it at 300 degrees Celsius, this molecule will decompose, giving you hydrogen bromide as a byproduct, and you will get CH2, double bond CH2, ethene as a product. So whenever an alkyl halide is heated, again, alkenes are formed. So the decomposition follows the following order. Decomposition. Iodides will decompose easily compared to bromides and chloride because the bond between carbon and iodine is longer and weaker. Longer the bond, weaker. So iodides will react more compared to bromides, and bromides will react more compared to chlorides when same alkyl groups are present. And tertiary, secondary, primary. Tertiary is more reactive compared to secondary and primary when same halogens are present. What does it mean? Tertiary alkyl halides R, and X. This will be more reactive compared to secondary R, C, R, H, and H. This is secondary, and this will be more reactive compared to primary when same halogens are present. All right. Next, other reactions, they're called as miscellaneous reactions. All right. So some of the reactions like reduction. Now, alkyl halides on reduction, what is formed? Alkanes are formed. Now, what is reduction in organic chemistry? The reduction is addition of hydrogen. Addition of hydrogen or the removal of oxygen. Now, reducing agents. What are the reducing agents? Zinc in dilute HCl, sodium in alcohol, zinc copper couple, or lithium aluminum hydride. All these will give nascent hydrogen. All this zinc in dilute HCl, sodium in alcohol, zinc copper couple, lithium aluminum hydride, all this will give nascent hydrogen. What do you mean by nascent hydrogen? Hydrogen in atomic state is called as nascent hydrogen. Hydrogen in atomic state, which is represented in square brackets, is called as nascent hydrogen. All right. Now, alkyl halide, for an example, if you take zinc and dilute HCl, sodium and alcohol, or zinc copper couple, or lithium aluminum hydride, they will give you nascent hydrogen. Since it's a reducing agent, they'll give nascent hydrogen. What happens? One of the hydrogen will react with bromine to form HBr. It is not 2Br, it is H. One of the hydrogen reacts. In place of Br, H goes. So what happens? I'll get CH3H. So alkanes can be prepared by reducing alkyl halides. When alkyl halides are reduced, the product what we get is alkanes. The next reaction, Wood's reaction, you would have learned it in POC, but anyways, we will learn. Wood's reaction is the name of a person. Now, what is this Wood's reaction? It's a reaction between alkyl halides and sodium metal. So this is ethyl bromide, and this is also ethyl bromide. Now, this ethyl bromides, when heated with the sodium in dry ether, ether is a solvent and it should be dry. It should not have water. If it has water, it will undergo hydrolysis. So what happens is this Na and Br gets eliminated as 2NaBr. So what else you have? You have C2H5. You have a single bond C2H5. This is also an higher alkane. The name of this alkane is butane. So Wood's reaction is the reaction between alkyl halides And what metal? Sodium metal in what? Dry ether. So what is the product you get? The product what we get is alkanes. Did you follow this?
Yes, sir.
So two reactions, miscellaneous reactions we learned. One is reduction of alkyl halide. So alkyl halides on reduction gives alkanes. The second one is alkyl halides, where not alkyl halides when it's allowed to react with sodium metal in dry ether. Again, alkanes are formed. It's called as Woods reaction. Next one, reaction with magnesium. Reaction of what with magnesium? Alkyl halides. Now C2H5Br. This alkyl halide, when it is heated with magnesium in dry ether, what happens is magnesium gets bonded between carbon and bromine. So you get C2H5, you have what? Magnesium and bromide. So it is named as alkyl magnesium bromides. So the alkyl group is ethyl, therefore it's named as ethyl magnesium bromide. Ethyl magnesium bromide. Did you follow?
Yes, sir.
And you can see the general reaction RX, alkyl halide, will love to react with magnesium. You get RMgX. This RMgX is called as Grignard reagent. The general representation of Grignard reagent. Grignard is a person. All right. The importance of Grignard reagent is Grignard scientist gets a Nobel Prize for this discovery because using Grignard reagent, we can prepare any organic compound. What do you mean by you can prepare any organic compound? Using RMgX, we can prepare alcohol, ether, aldehydes, ketones, carboxylic acids, or any organic compound can be prepared using Grignard reagent. That is the advantage of Grignard reagent. So they can ask you for 1 mark. What is the general representation of Grignard reagent? The general representation of Grignard reagent is RMgX. R can be an alkyl group, or it can also be an aryl group, benzene ring, aryl group. So it's named as, here it's ethyl magnesium bromide. Reaction with other metals. Organometallic compounds are formed. What is organometallic compounds? Metal, whenever it's directly bonded to the carbon atom of the organic group, then it is called as organometallic compound. Now, example here, this is an example for organometallic compound, C2H5MgBr. Grignard reagent is an example because you can see magnesium is directly bonded to carbon. Therefore, it is an example for organometallic compounds. What's organometallic compounds? Organic compounds in which metals are directly bonded to the carbon atom of the organic group is called as organometallic. Now, reaction with other metals, organometallic compounds are formed. Now, you can see here, it is C2H5Br, C2H5Br. When it's allowed to react with the zinc, 2 moles of zinc. So 2 moles of zinc, I'll write like this for our understanding. So what happens? Zinc bromide gets eliminated, ZnBr. The other zinc atom gets bonded, like you get C2H5, Zn, and you get C2H5. Now, the zinc is directly bonded to the carbon atom. Therefore, it's called as diethyl zinc. It's called as diethyl zinc. This reaction is called as these are called as Franklin reagents. When heated with zinc powder in ether, alkyl halide forms dialkyl zinc compounds, and these are called as Franklin reagents. Oh, right. Now, similarly, you can see here, these all are called as what? Organometallic compound. Now, when heated with lead sodium alloy, ethyl bromide gives tetraethyl lead, which is used as an anti-knocking compound in petrol. So tetraethyl lead, C2H5 4 times Br. This is called as an anti-knock, which will prevent the friction in the piston in the engine. That's called as what? Anti-knocking agents. So tetraethyl lead. Likewise, when alkyl halides are allowed to react with lithium, alkyl halides reacts with lithium in dry ether to form alkyl lithiums. So C2H5Br, one lithium and one bromine gets eliminated as LiBr. In place of other bromine, what goes lithium? So you get C2H5 and lithium. So it's called as alkyl lithiums. Similarly, the lithiums are similar properties with Grignard reagent. These are reactive reagents also. So we have Friedel-Crafts reaction, substitution reaction, all that. And we'll learn some of the questions in the next class, and then we'll go for mechanism. So we need time to prepare to finish with this chapter. So today we have learned with many reactions. I hope you followed.
Yes, sir.
Yes, sir.
Of the class today, we'll have the class on Friday. All right, ma'am?
Thank you, sir. Okay, sir.
Ma'am.